Hello! Oops. Okay, got it. Okay, so have you lost your package to some random dude online because he doesn't know how to give it to you properly?
Yes.
Absolutely, that's the problem we are solving. So what is it we are doing in this wonderful project of ours? We took a few items and throw it off the building because
Why not?
first of all, it is a very interesting thing to me to throw things off the building in the first place. Okay, so after referring some of my wonderful notes, I just remembered our project is based on a drone dropping package system where people usually would like to have their items being given straight to them. So we took a challenge to analyze the things we should and need to know about a drone dropping package system. So we basically bought cheap objects that can be broken and measured on different heights, and we just throw them off the building. Here's how our experiment was conducted. We take 14 Mummy Monster packs and we put them in groups of 2, and both of which are being thrown off a building. But one of them is being thrown off as a singular pack, while the other is being thrown off with a parachute and a cushion system. All 7 of these groups would be thrown off different floors ranging from the 1st floor to the 7th floor. When I say the 1st floor, I actually mean throwing the pack off the balcony from the 1st floor to the ground. For context, this is what we've done. The packs I'm opening now are the packs of the paraglided and the cushioned Mummy Monsters. They look fine, but well, compared to the solo fallen ones, they are much more crushed than the protected ones are. If you have a keen eye, you might realize that some of the high dropped ones have lesser damage compared to the ones from lower drops with higher damage. Well, as you see here, some of the Mummy Monsters hit on their sides first and some of them hit on the grass, but some of them hit face first, which is the thing that causes the difference. Well, so if you're wondering, how did we compute and analyze all of this thing in the first place without actual height data, which this was our first estimate, which isn't really good. So how did we do it and manage to get the correct building height? Because we never knew the contractors that built this place, so we couldn't just find them and ask them that question. So we have a very simple solution.
Boarding height, we measure the height of the window frame and height of the balcony and height of difference between window frame and balcony. This idea. When we found a shot of our dormitory perpendicular to the window. We find that the distance between the top of the window frame from the floor below to the base of the window frame from the floor above is exactly 1 window frame height, which is how we got the height of drop of experiment.
My name is Kevin. Check it out. From our first experiment, when the Mummy Monster being thrown without protection, it breaks more as the fall height increases. But it also has been observed that the time taken to fall is not following the standard of h equal to g bracket e squared bracket 1/2. This was then noticed by us to adjust the equation based on air resistance. Regarding the main issue is preventing damage to the parcel dropping off the building. We use cheap bubble wrap technology to increase the contact time of the Mummy Monster pack or our parcel with the ground upon landing. Then added a cheap single-use parachute with a holes cut in it like a standard human parachute to ensure slow falling and reduces the effect on wind. The material we use for the parachute is a piece of paper, proving that the parachute can be made cheap since it's a single-use system.
Okay, that's very interesting at all. Finding very interesting variables based on other interesting variables. So we have one problem. We still don't know what is the equation representing the fall time with in terms of air resistance. So let me show you a great example equation here. We come up with this problem where we see a bunch of these scary things online. So how do we end up with any one of them? We pick the simplest one, the one with terminal velocity, because that's only one thing. It's either we pick the drag coefficient, which is inside the terminal velocity, or we go with something else, which is just the terminal velocity by its own. Yeah, that's what we did. So we got a bunch of values of the possible terminal velocities and we just averaged them up. How we did it is very interesting.
Hello, my name is Kavinish Analysing and today I'm going to explain about the calculation that we did for our experiment. Okay, to start off, we started with the basic kinematic equation, which is S equals to ut plus 1 over 2 at squared. U is the initial, so since our initial is 0, the t will be cancelled out because when 0 times t, you won't get anything. So the balance is 1 over t. A is gravitational acceleration, so we change it to g, and then t squared, we just write it back. For S, it's actually the height, so it becomes h equals to 1 over gt squared. But then we have a problem where in order to use this equation, there is air resistance, so we don't know what is the air resistance. So in order to get the air resistance in the formula or in the equation, we searched Google and Google said, okay, in order to find the V value, we tried to use the algebraic method, but then we found out that it's impossible to find V value with algebraic method. So we asked calculator to solve it for us, but then we need to substitute the value of H, G and also T. For the H value, we took the first recorded value, which is 1.182, and then for time, we took 0.55, and for gravitational acceleration, we used 9.79, which is at Malacca gravitational acceleration. Okay, when you type all of this in the calculator, you'll get a result of 4.073457732 meter per second. And then same goes to the other height.
So from our wonderful analysis and hard work, we could just find the function of the falling mummy monster parachute thing using the same method. We'll get an equation that the drone would probably have a computer to deal with it anyway, so you would just know what parachute, like it will switch between parachutes based on what kind of object it is. If it's heavy enough, you give it a big parachute. If it's light enough, you give it a small parachute to save cost and to protect the object. Thank you.